This set of videos is about research in psychology. It's appropriate for students in introductory psychology courses. We're going to cover the scientific method and how it's used in psychology. We'll look at different types of research that psychologists use, such as correlational studies, experiments, and so on. And we'll spend some time talking about how you evaluate the results of some psychological research. Let's start by looking at the scientific method. And the scientific method is essentially identical regardless of which field of study you're in. So it's used in psychology, but it's also used in physics and chemistry and biology and so on. And it's really just a set of steps, and it lays out probably the best way that we have of actually learning about something in an objective, empirical manner. And we're going to talk about all of these steps in a bit more detail, but let's just review them all here briefly. So the first step in the scientific method is starting with questions, and these questions can be about anything. These are observations about the world or about people, wondering what makes people tick, why they act in certain ways in certain situations, and so on. So just initial curiosity about something is the first step in the scientific method. The second step is turning that curiosity and those questions into something testable, into a testable hypothesis, and we'll discuss this in some more detail in a minute. But essentially a testable hypothesis is your prediction about what you think is going on in terms of whatever the question is that you have. In the third step, the researcher designs the study that will test the hypothesis, and there are many different research designs that psychologists use. We'll look at some of these in some more detail in a minute. Then the researcher has to actually do the study and collect the data. That's the fourth step. And in the fifth step, then the task then is to analyze the results, to look at the data, analyze the results, and interpret them, and try to decide do they actually support the prediction? Do they support the hypothesis that you made back in step 2? In the last step, the researcher shares his or her findings, and this is done by publication, it's done by presentation at conferences, because science is essentially a public activity, and it's important to share the results, and then the results then go on to inform the decisions about what to do next. So what you really have here is like a circular process. It starts with step 1, you work through down to the last step, and what you come up with in the last step often informs what you're going to do in the next step 1 in the next cycle. So that's essentially the scientific method. We're going to look at these steps in some more detail. So let's go first of all to look at the first step. Curiosity is what initially drives science, and you can think of examples from the history of science where people made scientific discoveries just by observing what was going on in the natural world. That's how we came to understand how gravity works. It's how we came to understand all kinds of things in the natural world, like the seasons and the relationship between the sun and the earth and the moon and so on. And so psychologists use the same kind of curiosity in observing people and in wondering why is it that people act the way they do or feel or think in particular ways. How do they learn? All kinds of questions about human behavior. That's where psychologists come up with some of their questions, is just by observing people. They also sometimes use theories to drive their research questions, and a definition of a theory is an organized system of assumptions that explains phenomena and their interrelationships. And we have theories like the theory of evolution that drive our research questions, and we might come up with predictions about the way people act or behave in particular situations using either observations or things like theories, like the theory of evolution, for example. So the initial driving force in science is simple curiosity. Okay, so we're moving on to the second step in the scientific method, and that's turning that initial curiosity or those observations about the world into something a little more structured and systematic. And in this instance, what we're doing is coming up with a testable hypothesis, and that's what we're going to talk about next. A hypothesis is the researcher's prediction about what they think they're going to find. So if, for example, you think that you've created a new drug for, let's say, arthritis, and you think that this drug will alleviate arthritis, then your prediction is that my drug X, if taken 3 times a day for 3 months, taken on a daily basis, will reduce the pain of arthritis or reduce the swelling of arthritis or something like that. So the hypothesis is simply your prediction about what you think you'll find. Now, a hypothesis has to be testable. It has to be testable, and that means that you have to be specific enough, explicit enough, and concrete enough in what you state you think you will find that you actually are testing that thing. So if, for example, you have a hypothesis about the usefulness of running as an exercise for people, and you think that running will increase people's health, then you have to come up with a testable hypothesis for that. To say that running is good for people is not a testable hypothesis, because it doesn't tell us how much running for how long, running for how often. It doesn't tell us what good for means. Does it mean that you feel better? Does it mean that you lose weight? Does it mean that your blood pressure goes down? Similarly, people is not very specific either. Does it mean that running is good for all people? Is it as good for people who are 70 as it is for people who are 20? So you can see then that the statement running is good for people is maybe an intuitively accurate prediction, but it's not a testable hypothesis. So a better testable hypothesis would be this one. Running for 30 minutes, 3 times per week, for 3 months will result in lower blood pressure than walking for the same amount of time. And you can see then that this is testable because it actually specifies all of the variables that are under study. We can see here that there's a particular time period that we need to be concerned about, and there's an outcome measure here that's specified. In this case, it's blood pressure. Okay, so that's what making a testable hypothesis means. The hypothesis also has to be falsifiable. And a falsifiable hypothesis is one that, if your prediction is wrong, if running does not decrease your blood pressure, then you'll be able to design the study that will show that your hypothesis is wrong. So you can't make a hypothesis that won't allow you to be wrong. Your hypothesis needs to be able to be testable in the way that your results will prove you either right or wrong, and it has to work both ways. And for this to be the case, all of the variables in the study have to have an operational definition. And an operational definition is simply a definition in terms of how the variable is going to be measured. So if we say that we're going to measure blood pressure, then we need to understand what are the units of blood pressure, and that's how we're going to define blood pressure. You could define a variable like pain, for example. Let's say that you have come up with a way to reduce pain. An operational definition of pain could simply be a self-report rating of pain. You could ask someone, how much pain are you in on a scale of 1 to 100? And they would just rate it wherever it was. The self-report rating of pain would be your operational definition. So it's very important that you understand how you're defining all of the variables in your study. It can't be vague and general like health. It has to be something specific, explicit, and concrete, like blood pressure, like a self-report rating, and so on. So back to our list of steps in the scientific method, and we've talked about starting with questions and then turning those questions into a testable hypothesis. And the next step then is selecting the research design that will allow you to test your hypothesis. Psychologists use a variety of different research designs. There are many different types of studies, such as descriptive studies, experiments, correlational studies, and so on. So the task in this step is to find the right research design to fit the hypothesis that's under study. We'll talk about these in some more detail in a minute, but for the time being, let's go back and just review the rest of the steps in the scientific method before we look at these different research designs in more specific detail.